This video talks about finding values from a graph, but I want to go back to what we did on the last video on domain and range, just with this first picture, just so I can explain a little more. So see right here, there's an arrow. That means that graph continues in that pattern, beyond the graph paper. And there's also an arrow here. So if I were to say if I were to ask you what's the domain, which this question doesn't ask, but I'm just trying to give you some extra information here. The domain for this function would be from negative infinity to infinity, because all the x values keep going, right? Like there and there, the graph keeps continuing. Now, interesting here, what's the range for this function? Well, the range, so domain, left to right. Range, bottom to top. So the range is going from this value here, which looks like to be -2, up to +2. And this would be an interval notation because, see, there are values all the way in between. There's outputs all the way in between -2 and 2, and including -2 and 2. So you would write the range like that. So I just wanted to talk a little bit more about domain and range and how to read those off a graph. I'm sure it'll come up again, but I thought maybe another example might be helpful. So I'm going to erase all this, get it out of our way. And now we'll actually do the problem. Okay, so it wants you to find values off this graph. And so it says f of 0. So this is, I don't know that it's labeled anywhere, but this graph is the f function, okay? So if you want to know what f of 0 is, you're saying when x is 0, right here it's on the graph, what's the y? Well, f of 0 in this case happens to equal 0 because it actually goes through that point. You know, the input's 0, the output's also 0. Okay, now let's look at another one, f of 1/2 pi. So you go to 1/2 pi on the graph on the x value, and then you have to read to where the graph is. So in this case, it's reading up there to 2, and so you would say f, so this is part B, I wish there were a little more space here, f of 1/2 pi is equal to 2, okay? And then C, I'll just recopy it here, f of -3/2 pi. So now you're going to say this is your x value, so you're going to go over here to the x value, -3/2 pi, which seems to be right there, and you're going to read to the graph. So it looks like it also goes to 2, so that also equals 2. Okay, now the question changes a little bit. So on the A, B, and C, they were saying f of, and they were giving you an x value. But now here it says in D, find the values for x. So you're going to find the x values when f of x equals 0. Well, this is going to be a little weird because, let's see, I'm probably going to have to erase what I already have written. Okay, so they're saying, when do you get an output of 0? And we're talking then about the x-axis. Okay, that all those points, there's one there, they haven't, it's going to continue, right? So you're not going to be able to list all the x values. You're going to have to represent that somehow. And so you can say, well, it looks like it's going 0, pi, 2 pi, and in the other direction, -pi, -2 pi. So you could say something like, let's see, we're finding x is equal to, you could just kind of show a roster is one way you could do it. So you could say it's -2 pi, -pi, 0 pi, 2 pi, and then it's continuing on in that direction. And that probably makes some sense. Another way, though, they can write it, x is, well, we could say an element of the set. I don't think you're going to like this one. X such that, well, I don't like it now either. Okay, But let's not do that because we don't know that notation. So let's think of another way to write this. It's the set of x such that, that's what that line, that's how that line's read, such that x is equal to n pi, where n is an integer. And that kind of covers it right there. They might write it even without the set notation and just say x is n pi, where n is an integer. So you take any integer, 0, 1, 2, -1, -2, and times it by pi, and those are the x values where the output is 0. That one's kind of confusing, I will give you that. But we'll go on. So what are the x-intercepts? Well, the x-intercepts are all of those that we just said, right? So it's the set of x such that x is equal to n pi, where n is an integer. Yeah, there's other ways to write this with set notation and all of that, but maybe that helps. So check the book out and see how they write it just for fun. These are acceptable. I've got a couple different ways there. So now it says find the y-intercept. Well, good news. If it's a function, and this is a function, it passes the vertical line test. We didn't talk about that, but if you go back and look, it does pass the vertical line test, so it is a function. This is actually a trigonometric function, but take trig, that's a fun class, not this class. Okay, but if it's going to be a function, you can only have one y-intercept. So the y-intercept is at 0, 0 in this case. So you can see it. Let's see, I'm going to go back up. There's the y-intercept right there. That's the only point on the y-axis, is that one right there. Okay, so that's a little bit easier to do. If there's going to be a function, you can only have one y-intercept. You'll notice, though, that on the x-intercepts, we had an infinite number of x-intercepts.